Welcome to QuickBytes Education. Today's QuickByte is all about immutable infrastructure, explained simply, quickly, and clearly. Let's get started. If you're studying for the KCNA, the Kubernetes and Cloud Native Associate exam, you need to understand immutable infrastructure. Why? Because Kubernetes, containers, and cloud-native systems are built around the idea that we replace broken or outdated resources instead of manually fixing them forever. By the end of this video, you'll understand what immutable infrastructure means, why it matters, and how it connects to pods, containers, images, and the exam. Here's what we're covering today. First, what immutable infrastructure means. Next, the difference between mutable and immutable infrastructure. Then we'll connect it to Kubernetes and containers. And finally, we'll cover the common exam trap most beginners miss. Immutable means something does not change after it is created. So immutable infrastructure means that once a server, container, virtual machine, or workload is deployed, you do not manually change it in place. Instead, when you need an update, you create a new version and replace the old one. Think of it like a printed textbook. If one page has outdated information, you usually do not grab a marker and edit every copy by hand. You publish a new edition. That is the basic idea. In tech, instead of logging into a running server and changing settings manually, you build a new version with the correct settings and deploy that new version. On the KCNA exam, they may test this by asking what immutable infrastructure does when a change is needed. The answer is, replace the resource instead of modifying it directly. That visual is the whole concept. Mutable means change it in place. Immutable means replace it with a new version. Now let's talk about why this matters. When people manually change running systems, those systems can slowly become different from each other. That problem is called configuration drift. Configuration drift happens when the real environment no longer matches the expected version. Maybe one server got a manual patch. Maybe another server has a different setting. Maybe someone made a quick fix during troubleshooting and forgot to document it. Over time, the environment becomes harder to trust. Immutable infrastructure helps reduce that problem because changes are made through new versions, not random manual fixes. On the exam, they may ask why immutable infrastructure is useful. The exam-friendly answer is that it improves consistency, repeatability, reliability, and easier rollback. So far, immutable infrastructure means you do not patch or reconfigure running resources by hand. You build a new version, deploy it, and replace the old version. That helps prevent configuration drift. Now let's connect this to containers. A container image is a packaged version of an application. It includes the application code, dependencies, libraries, and settings. Once you build that image, the image should stay the same. If you need to change the app, you do not usually go inside the running container and edit files manually. Instead, you build a new image. Then you deploy containers from that new image. This is a major reason containers fit so well with immutable infrastructure. The image is the versioned package. The container is the running instance. When something changes, you replace the running container with a new one created from a newer image. On the KCNA exam, they may test this by asking how containers support consistent deployments. The answer is that container images package the application and dependencies, so the same version can be deployed repeatedly. Kubernetes also follows this idea. Pods are not meant to be treated like permanent machines that you log into and maintain forever. Pods are temporary and replaceable. If a pod fails, Kubernetes can create a new one. If you update a deployment, Kubernetes can create new pods using the updated container image and remove the old pods. That is immutable infrastructure in action. You are not usually editing the running pod manually. You update the desired state, and Kubernetes works to make the actual state match it. Here's where most people get this wrong. They think immutability means nothing ever changes. That is not the point. Things do change. Applications get updated. Security patches happen. Settings improve. But the change happens by creating and deploying a new version, not by manually changing the live resource in place. For the KCNA exam, remember these key ideas. Immutable infrastructure means replace, do not manually modify. Mutable infrastructure means change the existing system in place. Configuration drift is when systems slowly become inconsistent because of manual or untracked changes. Containers support immutability because new versions are usually deployed as new images. Kubernetes supports immutability because pods are designed to be replaceable. So if an exam question talks about consistency, repeatable deployments, reducing drift, or replacing resources with new versions, think immutable infrastructure. Here's what you just learned. Immutable infrastructure means deployed resources are replaced instead of manually changed. Mutable infrastructure means existing systems are modified in place. Configuration drift happens when systems become inconsistent over time. Container images support immutability because new versions are built and redeployed. Kubernetes supports immutability because pods are temporary and replaceable. The big KCNA takeaway is this. In cloud-native systems, you usually do not fix running resources by hand. You build a new version and replace the old one. Like, subscribe, and keep building your knowledge with QuickBytes education, one QuickByte at a time.